Hi everyone, I'm Juliana Gian Boca from 12 Mundel, and today I'll be discussing how to solve static equilibrium problems. So first, our lesson outline is what is static equilibrium and the conditions for static equilibrium and solving static equilibrium problems. So first, what is static equilibrium? It's a state where an object is at rest and the total or net force acting on it is zero. This means that all the forces around the object are balanced, so there's no movement or acceleration happening. So what happens when the forces are balanced? The object stays still, it doesn't move or accelerate. And examples of static equilibrium problems is a book resting on a table is in static equilibrium. The weight of the book pushes down, but the table pushes back up with an equal normal force. Another one is a picture frame hanging on the wall. Gravity pulls it down, but the tension in the string and the nail support balance it out, keeping it still. So why don't these objects move even though gravity is acting on them? It's because other forces, like the normal force or tension, balance gravity perfectly. So there are conditions for static equilibrium. For an object to be in static equilibrium, two conditions must be met. First, there should be no net force, meaning all the forces cancel out. Second, there should be no net torque, so the object doesn't rotate. When both are true, the object stays completely at rest. What are the two conditions of static equilibrium? The answer is no net force and no net torque. So here's a sample problem. Now let's solve an example. We have a 10 kilogram box supported by a wall and a floor. We need to find the normal force N sub x and N sub y exerted by both surfaces. The given is the mass is 10 kg and the weight equals to m times g, so that's 10 times 9.8 equals 98 newtons. Vertically, the upward normal force from the floor Ny or N sub y must balance the weight of the box. So N sub y equals 98 newtons. Horizontally, since there's no motion and no horizontal force, N sub x or N sub x equals 0 newtons. So which surface gives the greater normal force, the wall or the floor? It is the floor because it supports the full weight of the box. So the normal force from the floor is 98 Newton and the force from the wall is 0 Newton. That's how we can tell the box is in static equilibrium. All forces are balanced. Thank you for listening.